Welcome back to the linear algebra session again. Today we are going to start with an example of solving a system of linear equation. Then we will discuss the reduced row echelon form of a matrix and then use reduced row echelon form to find inverse of a matrix. Let us begin with this example. Find for what values of a and b the system of equations x plus y plus z equal to 2, 3x plus y plus 2z equal to 2 and 2x plus 2y plus az equal to b has unique solution, infinitely many solution and no solution. We begin by writing the coefficient matrices. So here the coefficient matrix A is 1, 1, 1. Now look at the equations. We have the coefficients of x, y, z in the first equation are 1, 1, 1. So the first row is 1, 1, 1. Second equation has the coefficient as 3, 1, 2. The second row is 3, 1, 2. And the third equation has the coefficient 2, 2a. So it is 2, 2a. X is x, y, z and b is 2, 2b. Right hand side entries of the equations. So we start with the augmented matrix. We start with the augmented matrix AB. So the augmented matrix is A itself and then B is augmented at the end of A. So here the first non-zero column is the first column itself and the topmost entry is non-zero. So this is my pivot entry. This is my pivot entry. We apply now row operations to reduce the entries below the pivot to 0. So I will reduce this 3 to 0 and 2 to 0. And the operations we are going to apply is R2 goes to R2 minus 3 into R1. Because 3 minus 3 into 1 makes it 0. And then R3, 2 minus 2 into 1 will make it 0. So R3 will go to R3 minus 2 times of R1. So we are not changing the first row. So we are changing only second row and third row. So we will begin with the first row as it is. So 1, 1, 1, 2 as we have here. Now apply the operation R2 goes to R2 minus 3 minus R1. So it gives you 3 minus 3 into 1, 0. Then 1 minus 3 into 1 minus 2. 2 minus 2 into 1 makes it 2 minus 3 into 1 makes it minus 1 and 2 minus 3 into 2 makes it minus 4. Then second operation R3 goes to R3 minus 2 into R1. So that makes it 2 minus 2 into 1, 0. 2 minus 2 into 1, 0. And then A minus 2 into 1, A minus 2. B minus 2 into 2, B minus 4. So the first pivot is this one. Now look at this matrix now. So we have got the pivot of this column, this row. So we'll concentrate on this portion of the matrix. So here the first column is this one, non-zero column, and the topmost entry is non-zero. So this is my second pivot. Once this is second pivot, all entry below the pivot should be 0. But it is already 0 here. Okay, so we don't have anything to do. Now we will go for the third pivot. Now look into this matrix, and here this is got pivot, so this column and this column we will leave, so we will concentrate on this portion. So here the first non-zero entry is A minus 2, but we don't know A. So A may be 2 also. If in case A is 2, it is 0. And in case B is 4, this is also 0. So here are different possibilities of A and B need to be considered. If A is not 2, then this term will be non-zero. So this will become my next pivot. But anyway, we are going to stop here, and then we are going to consider different cases of this. So notice that this is in, which is in REF, which is in REF, but not exactly. So what we are going to do now, we are going to consider different cases of A and B. So first case we are going to consider is case 1. A is not equal to 2 and B is B can take any value. So what it will represent in this case? If A is not equal to 2, then this is non-zero. So this becomes the pivot in that case. So the row echelon form of AB is 1, 1, 1, 2, 0, minus 2, minus 1, minus 4, 0, 0, A minus 2, B minus 4. See, this is your first pivot, this is your second pivot, and A minus 2 is non-zero. So this is your third pivot. So that's why it is in row echelon form. Every row got its pivot. And so rank of AB is equal to 3. And row echelon form of ABA is, row echelon form of A is 1, 1, 1, 0, minus 2, minus 1, and 0, 0, A minus 2. Remember, this is your first pivot, this is second pivot, and A minus 2 not 0. So this is your third pivot. And so rank of A is equal to 3. Rank of A is equal to 3. Now, so what we got here now? Therefore, rank of AB is equal to rank of A is equal to 3, which is equal to number of unknowns. So what is the case? This means rank of AB, rank of A equal means the system is consistent, and when it is equal to 3, the number of unknowns, the system has a unique solution. So the system is consistent and has an unique solution. Remember, consistent comes from the fact that these ranks are equal, and the rank is equal to number of unknowns represents that, ensures that the system has a unique solution. So we are done. We have not been asked to get the solution, so we are leaving here. Now come to the matrix again, come back to the matrix again. Now here, first case we have considered A is not 2, but B can take any value. The second case we are going to consider is A is 2 and B is also 4. A is 2, B is 4. So it means this is 0 and this is 0. So this row will reduce to 0 row. Okay, so second case we are going to consider is case 2. A is 2 and B is 4. In this case, the REF of AB is, so RE of AB is 1, 1, 1, 2, 0, minus 2, 1, minus 4, 0, 0, 0, 0. So the pivots are, this is pivot and this is pivot in this case. So how many non-zero rows in this case? 2 non-zero rows. And so rank of AB is equal to, so rank of AB is equal to 2. Also, REF of A is, you just take the first 3 columns. So 1, 0, 0, 1, minus 2, 0, 0, sorry, 1, 1, 0. And so rank of A is equal to 2. So therefore, what we are getting now, rank of A, B is equal to rank of A, and that is equal to 2 less than number of unknowns. Now unknowns are 3, x, y, z. So the system is consistent and has, because it is less than the number of unknowns, rank is less than the number of unknowns, so has infinitely many solutions. This is the case under which the system will have infinitely many solutions. Now again come back to the matrix. So here, if I take A minus 2, 0, it means A equal to 2 and B not equal to 4. What will happen? This will become 0 and this will become non-zero. So this will become pivot in that case for the third row. So let us take that case now. So case 3, A is equal to 2 but B is not equal to 4. So in this case, REF of AB is 1, 0, 0, 1, minus 2, 0, 1, 1, 0, and 2 minus 4, A minus B minus 4. So here 1 is pivot, minus 2 is pivot, and B minus 4 being non-zero is pivot. And so what is, how many non-zero rows here? 3 non-zero rows. So rank of AB is equal to 3. Also, REF of A is first three row columns 1 0 0 1 minus 2 0 and then 1 1 0. Now look at this matrix. You have two non-zero rows here, and so rank of A is equal to 2. So what is our conclusion now? Since rank of AB is not equal to rank of A, comma, so the system is inconsistent. So it means it has no solution. So we have discussed and all the possibilities of A and B, under which the system of equation will have unique solution, infinitely many solution, and no solution. Remember, inconsistent represents no solution. Thank you.